Today we discuss about the UMAP, a new dimension reduction technique. Okay, so what is dimension reduction? How it helps in analysis process? Okay, and for that, this is the new technique we will use. So how we can use this technique? So UMAP. So dimension reduction. Dimension reduction is the converting or transforming high dimensional data into a lower dimensional space. Okay, so which helps us in visualizations. We can visualize data easily, noise reduction and feature extractions. So when we reduce the dimensions, we can identify the insights easily or fastly. Okay, so for that, this is the dimension reduction techniques are used. So common dimension reduction techniques are PCA, TS, TNS, TSNE, okay, UMAP. These are the different dimension reduction technique, and in that we will discuss the UMAP. Okay, so UMAP is the uniform manifold approximation and projection. Okay, so this technique is developed by the Leland McInnes at 2018. This is the new latest technique. It works on the nonlinear dimensionality reduction technique. It's a nonlinearly based data and preserves local and global structures. Okay, so this is the UMAP technique, and for the technique, we use the parameters like n neighbors, which holds the local and global balance, and minimum distance for the clustering tightness. Okay, these are the two parameters we apply for this technique. How we can use? So import the UMAP library, and with the help of that library, create the object for the UMAP reducer. This is the object, and with the help of this object, we can call the fit transform method and pass our data, whatever the data we want to uh, use or analyze for the dimension reduction. Okay, so likewise we use the UMAP. So how it works, mathematical intuition behind this UMAP technique. So this technique is based on the manifold theory and fuzzy topological structure. These are the two main base structures where the UMAP is works. Okay, so steps: construct the weighted k nearest neighbor graph. Okay, so find out the nearest neighbors and then estimate a fuzzy topological representation. So based on that, and then optimize low dimensional layout via SGD. Okay, so with the help of this technique, we can find out or we can generate the new data, which is the lower dimensional data. Okay, which where we apply this UMAP technique on high dimensional data, so we can reduce our dimensionality. Comparison, there are different techniques. So UMAP is nonlinear and preserves both local and global structures, where TSNE is nonlinear and focuses on local structures only. Okay, so and PCA is linear and interpretable but lacks for nonlinear capabilities. So these are the different techniques where we apply based on the data and based on the requirement. Okay, so these are the different techniques having different uh, advantages. So based on these advantages or based on these properties of these techniques, we apply on our data to reduce the dimensions. Advantages: so UMAP is fast and scalable, preserves both local and global structure, better clustering than TSNE, okay, compared to TSNE. So it's better clustering, and then general purpose embedding capability. These are the some advantages of UMAP technique. There are some limitations. Okay, there is a one main limitation is hyperparameter sensitivity. So where we apply the minimum distance and k neighbors based on that. Then non-deterministic output unless random state is fixed. Okay. So still, if we are not fixed random state, then we cannot determine the output and may not always be interpretable. So these are some limitations. Applications where we apply this UMAP technique is genomics, image processing, where we use the dimension reductions, natural language processing, and recommendation system. These are some applications where we apply the UMAP technique to convert the data from higher dimensional to lower dimensions. Okay. Then UMAP is a powerful tool for dimension reduction, ideal for large and complex data sets, okay, where we have large data sets. Then complements, or there are other techniques like PCA and TSNE. These are some techniques we already discussed. So based on the requirement, based on the data sets, okay, we apply these techniques to reduce the dimensionality.